Hi Year 7 and welcome to our third lesson all about the differences between atoms, molecules, elements, compounds and mixtures. Okay, so what I want you to do is just grab a pen and paper and write down what you think each of those words mean. So that's atom, molecule, element, compound and formula. You can pause the video while you do it, but I want you to get your thoughts out your head and into words before we start. It doesn't matter if you're wrong, because I'm here to just try and tidy up what you do know. Okay, now you've done that, let's see what it actually is. Okay, so an atom is the smallest thing you can have, the smallest part of an element you can have that can't be split up into anything else and still be the element. Now we know we can split it up into protons, neutrons and electrons, but then it stops being the element, doesn't it? It becomes subatomic particles. So that's an atom. A molecule is atoms joined together. Basically, you've got two or more atoms joined together to make a molecule. Molecules can be elements or compounds. An element is where you've got only one type of atom in the molecule, and a compound is where you have two or more types of atom in the compound. And the last one, the mixture, is where you have lots and lots of different molecules all mixed up but not joined together. Okay, so what do they look like? That's what we're going to do today. Now there's two ways of doing this. I like doing this way because then you can visually see the difference and why it's an element, why it's a compound. You might want to follow my video first, then do a simulation, or you might want to watch my video. You might want to do the simulation first. If that doesn't make sense, do the video. There's a worksheet to do at the end to pass back to your teacher as well. So, first of all, the website I want you to look at. Up to you when you go to this site, at the start, at the end, in the middle. It's phet.colorado.edu again. Then it's /simulation/build a molecule. So we're building a molecule this time, not just an atom. Okay, so what do things look like at the molecular level? It's difficult to picture. And so, luckily for me, I have got a modelling kit. You are very welcome to build your own molecules along with me. You might want to use Lego or something like that. Up to you. I'm not expecting you to have one of these at home. Okay, so first of all, we are going to look at something really simple. We started off last lesson by looking at hydrogen. Okay, so I'm going to start off this one by looking at hydrogen again. So I'm going to write it down. Name. Hydrogen. Okay, formula for hydrogen. Okay, we know that on the periodic table, hydrogen is H. But the formula, when you've got hydrogen in the air, in the air, as it were, as a gas, it's actually H2. That's because in hydrogen, there are two hydrogen atoms. That 2 means that there's 2 H's. So we are going to need 2 H's. Is it an element or a compound? Well, the atoms are all of the same type. So if they're all the same type, it must be an element. And so here we go. I've got 2 hydrogen atoms here. And what we need to do is we need to join them together. I've got a little join here. each hydrogen only has space for one join, one bond, we say in chemistry. So I can fit it together like this. So the diagram, you can do it one of two ways. You can either draw what you see, which is two white circles with a line through them, or you can write it out, and we've got hydrogen, line, hydrogen. Both of these are acceptable. Okay, so let's look at something else. Let's look at, say, iodine. Iodine has got the chemical symbol I2, which means there's two I atoms in it, like this. So, because all the atoms are the same type, it's also an element. And again, there's only room for one join. So it joins together like this. And that's going to look like two purple circles joined together. Or again, you could write it I. Can I just say one thing, okay? When it comes to writing formula, or formulae rather, because you're going to write more than one of them, can you please make sure each atom starts with a capital letter? So each new element starts with a capital letter. If there are two letters, which we'll look at in a minute, the second letter is lowercase. If you were to write it with a lowercase letter at the start, it would be wrong. Okay? And the other thing is, you've got to be really, really careful with your handwriting. I's can look like L's, can look like ones, which is why, just for when I'm writing with chemistry, I always put the little tops and bottoms on so we know exactly which letter we're talking about. Okay, so that's iodine. Let's look at something else, water. Now, the ancient Greeks thought that water was an element, so we're going to find out if they were right or not. Okay? Water. Okay, and we all know, well, I'm hoping we all know the formula for water, which is H2O. Capital O, because it's a new element. Okay, it shouldn't look like H20, it should definitely be a capital. I can't come round and check your work, so I'm telling you now, I'm assuming that somebody's got it wrong. It might not be you, it might be somebody else, but I'm assuming somebody's got it wrong because somebody usually does. So let's look at what's in the water. H2. So that means we've got H, we've got H, H2, HH, and then we've got an O as well. And that O is for oxygen. So here we go. Now let's take a look. Are these all the same type of atom? No, they are not. Good spot. They're different types of atoms. So that means it must be a compound. Okay? So then we've got to join it together. Now we know hydrogen only has one space for a join. This will become a lot clearer why in year 9 when you start on your GCSE, or year 10 when you start on your GCSE. If we join it to the hydrogen, then we end up with hydrogen and there's no room for oxygen. So we must have to join it onto the oxygen. Oxygen has room for 2. So there we go. This is what a water molecule looks like. Please note it isn't in a straight line. It's got this sort of space hopper sort of look to it. And this is how we're going to draw it. We are going to, I need a red. So I've got my oxygen here with my red. Joined to two white hydrogens. And let's just see if I can, colour in my oxygen. Excellent. Or if you wanted to do it with just the letters H, O, H. Next one I want us to look at is hydrogen bromide. Okay, don't worry if you don't know the formula for these. You will always be told an unknown formula. Carbon dioxide and water we'd expect you to know. So hydrogen bromide is HBr. Now, can I just point out something? And I know I'm going to keep going on about it because I've found, I've taught for a few years. I've found that I do have to keep going on about it. Capital letter, start of a new element. So what's in there? We've got a capital H, hydrogen. Next letter's a capital, it's a new element. And that's capital B. Next letter's small, so it's still part of this. If it was a capital letter, that would be hydrogen and boron, but it's not, it's Br. So HBr. Okay, we've got two different atoms, hydrogen and bromine. So that means it's got to be a compound. Another thing as well, look at my handwriting, okay? That's what my handwriting looks like when I'm writing a word. This is what my handwriting looks like when I am writing in chemistry. Chemistry formulae are great because it saves so much time. I can write H2O instead of water, I2 instead of iodine. But I can't write with beautiful stylized handwriting because it doesn't look correct. So please go back to how you were taught to write when you were 5. It might not be as beautiful as your normal writing. I don't care. I want you to get the mark in year 11 when you do your exams. So anyway, hydrogen and bromine. Again, we've only got one space for a bond, for a join in these. You'll find out why they're called bonds when you do your GCSEs. I'm not worried too much about that for now, but they're called bonds. Hydrogen and bromine. I'd normally do it this way round because it's hydrogen bromide, HBr. So let's draw it. Hydrogen attached to lovely orange bromine. And we can also write that as hydrogen joined to bromine. Okay, so now we're going to get a little bit more complicated. So far, all we've had are things that have got one join. Which, fair enough, a lot of things have got one join, and I'll show you a few more things with one join later. I want to do something which has more than one join, okay? And that's oxygen, which is O2. Okay, here we go. 2 oxygens, 2 oxygen atoms. That means it's got to be an element. And we can try joining it together. And if we just put one join in like this, we've got gaps. We don't like to have gaps in molecules. Molecules aren't happy if they've got gaps, so we can't do it like that. So instead, I'm going to take my very special long and bendy ones. And look at this. It joins to itself twice. Okay, so let's draw what that looks like. Okay, we have got two red oxygens joined to each other twice. Or if you were to write it, O double bond. Two joins, double bond, O. Okay, that's an element. Does the same thing happen in compounds? Let's find out. Let's do another common compound that you might have heard of. Given the game away, haven't I? I can write in C there for compound. Let's do carbon dioxide. Okay, which I think everyone knows is CO2. So which atoms are involved? C. O. O, because it's O2. So we need two oxygens. That little number only refers to the atom immediately before it. It's called a subscript, is the proper name for it, not a little number. You'll probably hear it called little number more often though. And that only refers to the atom or the element immediately before it. So we've got one carbon, two oxygens. Again, chemistry, brilliantly lazy. We never write the number one, mostly because it gets confused with I's and L's. Okay, so how's this going to fit together? Carbon has got 4 holes, 4 places for it to join. So let's fill all of those, because we've got a feeling that everything's going to be joined in here. Oxygen only has 2 places. This has got 2 spaces, this has got 2 spaces. Excellent. I love it when all the spaces match up. And this is what carbon dioxide looks like. Okay, if you do go to the website, which I mentioned earlier, which is at the top here, you can build your own molecules. You don't just have to sit and watch me doing it. I'm only going to do a few more. Okay, you are going to get 4 more molecules from me after this. Okay, and that's it. So carbon dioxide, that's what it looks like. And if we are to draw it out, we've got a red oxygen, a black carbon, and a red oxygen. And again, double bond. 1, 2, 1, 2. Oxygen, double bond. Carbon, double bond. Oxygen. Okay, so next one I want to do is the most common gas in the air, which is nitrogen. And the symbol for nitrogen is N2. There's a lot of 2s, aren't there? I'm not. We'll see some bigger numbers in a minute. Again, notice handwriting, chemistry writing. Make it really obvious if it's a capital letter or a lowercase letter. There's only one type of atom, so it's got to be an element. Which elements are there? So which atoms are there? N and another N. So we've got 2 N's. Okay, now nitrogen is interesting. It's got 3 spaces that you can put a bond in or a join in. So let's do it. Let's go 1, 2, 3. And it can only join to itself because that's all there is for it to join to. 1, 2, 3. So that is our beautiful little nitrogen molecule. How are we going to draw it? We are going to get the blue pencil. Actually, that's a really good question. Why are we doing them these colours? The reason we're doing them these colours is because that's the colour of the Molly Mod kit, and I'm just sticking to it. If you want to do other colours, you can do, but please make sure you know what colour is what. I know what colour is what for these. You can have any colour you like. It doesn't have to be red for oxygen, so long as you write down a little key on the side and say, you know what, my oxygen is going to be pink and my hydrogen is going to be yellow, and doesn't matter so long as we know what's what. Nitrogen's usually blue because the sky is blue. I think that's where that came about. And nitrogen makes up about 80% of the gases in the air, just under 80%. And again, we can write this as N for nitrogen, triple bond, N. Another good question, can you have a quadruple bond? Not really. The electrons here are all packed really together and they're negative. Do you remember last lesson I said that all the positives in the nucleus, if you didn't have neutrons, it'd be really, really unstable. Same for the electrons, okay? All of these negative electrons, all in this tiny little space between the two atoms. And these negative electrons, again, this time it's going to be like putting two south poles of the magnet together. If the positives were like the north pole, the negatives are going to be like the south pole. And they don't actually want to be this close together. Nitrogen is actually pretty unreactive. But if you tried to shove a fourth link in there, it just wouldn't work. They'd spring apart. Okay, just two more. I'm sure you're all sick of me talking by now. You want to go and build some. Go build them. Go make them out of Lego. Go enjoy. Anyway, last ones to do. So let's put a line through that. Methane. This is one of those ones that we do expect you to know. Methane is CH4. So we've got one C. Next one's a capital, so it's got to be a new element. Please, capitals, remember. And we've got hydrogen. And we've got 4 hydrogens. So that's 1, 2, 3, 4. So let's get them out. Okay. Different types of atoms. More than one type of element. It's got to be a compound. And what does this one look like? And this is what it looks like when it's all joined up together. Okay, this is methane. And we can draw it. We start off with our black carbon. 1, 2, 3, 4 hydrogens. This is a 2-dimensional representation of it. I know it's a 3-dimensional shape. You don't have to draw it 3-dimensional until you do A-level chemistry. So this is absolutely fine. And even at A-level, we still draw out methane like that. Okay? So that's what methane looks like. And this gas is the main gas that happens when you break wind. So there you go. That's something exciting that you've learned. What your noxious bottom gas looks like. Okay, next one's ammonia. Again, have to learn what ammonia is. NH3. So what's in there? Excellent. 1 N and 3 H's. Obviously, you've got more than one element there, so that means it's a compound. So, here we go. Let's see what it's going to look like when we've got all our bonds in. Ammonia. And this little molecule is what gives us the smell of wee. So we're really into our waste stuff now. And what does it look like? It's a nice blue nitrogen with 3 white hydrogens, or we can do it as H, N, H, H. You know, I do feel ever so sorry for you if you're watching my lessons and you're Russian. Not only do I have a dreadful attempt at a Russian accent in the first lesson, your H's and your N's are going to be ever so confusing. Very last one, hydrogen cyanide. You don't have to know this one. It's HCN, which means you've got a hydrogen. So that's hydrogen, carbon, nitrogen, and of course multiple elements means that it's a compound. What does it look like? It looks like this. And how do we draw that? And it looks like that when you draw it down. Okay then, year 7. So worksheet to do, and next lesson hopefully you'll be joining in with the practical work as well.